All right, two blocks here, P and Q, 8 kg and 2 kg. The two blocks move to the left at a constant speed of 2.5 meters per second there, and under a force or unknown force acting at an angle of 30 degrees to the horizontal there. 2.2.1 says state in transverse law of motion in words. In transverse law states that an object will remain at rest, or it will continue moving at a constant velocity, like we have up here, at constant velocity, unless a net force acts on it there. An object will remain at rest or continue moving at constant velocity unless a net force acts on it. If you got that one, 2 marks for that there. 2.2.2, draw a free body diagram for block Q. So block Q, then the free body diagram for block Q will have here the dot, gravitational force, from the surface, normal force, and from the string is pulling block Q to the left with a tension force, and opposing the motion is frictional force there. Opposing the motion is frictional force there. And although the question wants us to only draw the free body diagram for block Q, we always need both the free body diagrams there. For P as well, we need it there as well. 2.2.3 says, before that, block Q, P and Q experience a constant frictional force of 6 newtons and 2 newtons respectively. So it means the friction on P is 6 and the friction on Q is 2. And then it says calculate the magnitude of force F then. Now, we need the free body diagram of P there, especially the one that shows us how is this applied force acting in terms of its components there. So we have gravitational force again, normal force. This is just aside, by the way, in order for us to do calculations. So from the rope was pulling block P to the right with a tension force, and frictional force also opposes the motion to the right, even for P as well there. And then we have that applied force there. And then the applied force can be broken into the applied force. Let us break the applied force. The applied force is acting horizontally to the left, and vertically downwards there. And then this is how we are going to horizontally view the applied force there. So now, what we are going to do now is that we are going to choose a direction. We are going to choose to the left as positive as the blocks are moving to the left. We choose to the left as positive, and then after choosing left as positive, then we assign a direction to our forces there, our horizontally acting forces. So it means for this one, for Q, the tension that is to the left is positive, but the friction to the right is going to be negative there. And then this tension here to the left is going to be negative, the friction here to the left is going to be negative as well, but the applied force there, specifically its horizontal component, is going to be positive there. So if you focus on P, what we have is we have a positive horizontal component of the applied force minus the tension force minus the frictional force, because those are to the right there, is equal to mass multiplied by acceleration there. And if you focus on Q, what we have is we have a tension to the left that is positive and a friction that is to the right and is negative there, is equal to mass multiplied by acceleration there. Now, we're looking for the force, but we know that the horizontal component is equal to, the horizontal component is, when we calculate the horizontal component, is Fx, it's the force multiplied by cos theta there. It means for this one, we're going to be having the force that we're trying to calculate multiplied by cos of the angle there, dt there, minus Ft, minus frictional force there, and is equal to Ma there. And then now for this one, we're going to be having tension. Let's substitute the friction. The friction is 2, is equal to a mass of 2. Now, what is important to note here is that when we have constant speed or constant velocity, it means that the acceleration is 0. So for acceleration, we put in 0 there. So we have tension minus 2 is equal to 2 times 0 is going to be 0 there. And then transpose over to that side there, we have tension is equal to 2 newtons there. So we have the tension there. So we are going to be having F cos 30 minus, the tension is 2, the friction for P is 6, is equal to mass of P is 8, and the acceleration is 0 again there. 8 times 0 gives us 0, and then we have F cos 30 minus 2 minus 6 gives us minus 8. Transpose the 8, we have F cos 30 is equal to 0 plus 8 is 8 there. Then we divide both sides by cos 30 and divide here by cos 30. We want the cos 30 here to cancel, and we are left with F, and our answer is 8 divided by cos 30. 8 divided by cos 30 gives us a 9,24 there. We have 9,24 Newton, 9,24 newtons there. And then what we have here is we have 4 marks for the free body diagram there for Q, and we have 4 marks for this calculation here. So 1 mark on the formula, 1 mark for this substitution over here, 1 mark for this substitution over here, and 1 mark for the answer there. All right, so 2.2.4 then says is the direction of the acceleration for Q, but before that, the string connecting P and Q suddenly breaks while force F is still being applied. So if the string breaks, force Q, the tension for Q falls off. So the tension for Q falls off, so you don't have tension there. So the only force acting on Q will be the frictional force. Now, if the frictional force is the only force acting on Q, then Q will be experiencing a net force. The only force acting is frictional force. It will be experiencing a net force to the right there, in the opposite direction to its motion there. So that means that it will be slowing down. The Q will decelerate, it will slow down, it will experience a force in the opposite direction to its motion there. Hence, if the net force is to the right, therefore, it's like this. Let's start from there. The only force acting is to the right. The net force is to the right, therefore the net force is to the right, because the only force acting is to the right. And therefore, the acceleration being in the direction of the net force according to Newton's second law will therefore then also be to the right there. That's 2.2.4 there. The answer will be the acceleration will be to the right. That's because the only force acting there is to the right. That means the net force is to the right. Therefore, the acceleration is to the right there, according to Newton's second law there. Okay.